My name is Manfred Helber. I'm a Microsoft Most Valuable Professional in the category Cloud and Data Center. In this video, we will speak about how to plan for Azure Stack HCI solutions. If you watched the previous modules, you already know that we can start with a very small deployment of Azure Stack HCI, starting with just 2 servers and minimum 4 capacity drives. If we have a hybrid configuration, we need additionally to the hard disk drives, additional flash drives. In the flash layer, we always need minimum 2 drives. Additional drives and additional servers are typical in larger deployments, so we can scale up to 16 servers in each cluster. We can have several of these clusters and build a cluster set. Now the question is how to plan for such a solution, how to find out what's the best configuration for your workload. Microsoft provides us a new planning tool, the Azure Stack HCI Sizer. The Azure Stack HCI Sizer is actually in preview, but it works already very well. The URL is on this slide, but you can also access the Azure Stack HCI Sizer via microsoft.com/HCI. Microsoft.com/HCI is my preferred landing page for all the information I want to have about the Azure Stack HCI solutions in the market. So let's have a look in a live demo on the Azure Stack HCI landing page and the Azure Stack HCI Sizer. This is the landing page, microsoft.com/HCI. When you click on Find an Azure Stack HCI partner, you have 2 choices, 2 options. Discover solutions. We discovered solutions in a previous module in this Azure Stack HCI track. And we can plan a solution. When we plan a solution, here we have a button to launch the Sizer. So you can see on the upper right-hand corner, I'm logged in as Manfred Helber. It's required to log in with a Microsoft account here because you can see I have some previous plannings here. So you can store your plannings, you can reopen your plannings, you can redefine your settings. Let's create a new project. I will create a new project. The name is Planning 03, and I can add some project notes. So Azure Stack HCI videos here, and the Azure Stack HCI videos. You can keep additional notes and add additional notes at a later point of time. Let's create this new project. The first step in this project is that you have to select some basic values. The first thing is, do you only want to use integrated systems? We discussed this in a previous module. Integrated systems and validated nodes have the same level of testing. Microsoft has a standardized testing for testing Azure Stack HCI certified solutions. Not Microsoft does this testing, but the OEMs do the testing. And the testing is done based on a standardized process with the private cloud simulator. This private cloud simulator runs several days, and it ensures that all the validated nodes have an equal quality regarding the stability, regarding the compatibility. A validated node fulfills all these requirements. An integrated system has some additional values. In an integrated system, your vendor of the system must provide you firmware and driver updates via Windows Admin Center. For validated nodes, this is optional. For integrated systems, an OEM must provide the server core the secured core configuration in the future. Today this is an evaluation. In the future it will be required. For validated nodes, this is possible that they are secured core, but this is optional. In the integrated systems, you have the situation that the OEM provides such a configuration not only to his own support department, but also to Microsoft support. So you have several of these additional values, but the stability, the scalability, and so on is in the validated nodes same. And as we have seen in the Azure Stack HCI catalog, a few systems are integrated systems, but the mass of the systems in the catalog are validated nodes. So preferred CPU family. You can select between Intel and AMD. It depends on your preferred CPU platform. In the past, we had some limitations regarding nested virtualization in AMD. AMD didn't support nested virtualization. In Azure Stack HCI, we also have nested virtualization for the AMD CPUs. So you don't have a different feature set regarding the Azure Stack HCI features depending on your choice. But as you know, we have different hardware-related options based on our choice if we decide for AMD or Intel. So for example, regarding the maximum amount of cores in a single socket. Let's select Intel here. Preferred solution builder, here you can say, okay, give me any choice, or I can pick one of the vendors and I will choose for Primeline solutions here. You see a huge list of vendors here of OEMs, and I will pick the Primeline solutions. In advanced, we can choose the option require 2-node solution. Azure Stack HCI supports in the smallest deployment to have full redundancy in 2 nodes. For sure, you have additional costs if you have a 3rd node, 4th node, a 5th node. This means with this checkbox, you can tell the configurator, the sizer, to try to keep the whole workload on 2 nodes. High availability. What's the planned redundancy? N+1 or N+2? So when I choose for N+2, I can lose 2 nodes. And for sure, this has impact on the planned reserve capacity and the planned amount of nodes. Storage failures to tolerate. 2 is recommended. This means I can survive 2 independent storage failures. So for example, one server fails completely, in the other server, one hard disk drive fails. Or in 2 servers, a hard disk drive fails at the same time. Storage preferences, storage type. Will I accept any storage type, or will I prefer all NVMe or all flash including SSD, or hybrid hard disk configurations? This depends on your workload. When I choose any, I can see what the sizer provides as recommendation, and then I can redefine my settings to optimize it here. Resiliency preference. Optimized for capacity or optimized for performance? Do I need a huge capacity with a moderate performance, or do I need maximum performance, but for sure I have also capacity requirements? The capacity requirements are defined in the next step. Persistent cache, any in-memory cache, I want to have 1 GB. This is a typical default value. I want to plan for further future growth, 20%. For example, I can add the value here, and I can check I need memory expandability and I need storage expandability. These are choices you can select here. I will only plan with the 20% future growth. Do I want to use software-defined networking? Software-defined networking, the last option here, is a great technology. We have seen software-defined networking is part of the HCI stack. But software-defined networking is very complex to configure and it's optional. So if you are looking for an Azure Stack HCI configuration for virtual machine workloads, for Azure Virtual Desktop, for Azure Kubernetes services, for your single customer, then software-defined networking usually is an optional choice. So usually you will not configure it. If you need it, if you know you need software-defined networking, then you should check this checkbox here. We will see in a later module the configuration wizard for Azure Stack HCI. There we will see software-defined networking is an optional step. You can skip this step and configure a full functional Azure Stack HCI cluster suitable for traditional workloads. Let's go to next. This is the important step where we add our workload. Because this is the great thing at the Sizer. It doesn't recommend some configurations based on the idea of the OEMs or of Microsoft. It requests our planned workload. Let's say we have a workload, and this workload is a default server. And this default server is general workload type. We have a total count of VMs, maybe 10 of them. We have per VM details, virtual CPUs. We can choose for one, but it's not recommended to have only one virtual CPUs. Minimum 2 is perfect. If we have more virtual CPUs, depends on our workload. So 4 virtual CPUs are usually not the default configuration for a typical default server. Virtual CPU to physical CPU relationship 1 to 6. So this is the over provisioning we accept. Memory 4 gigabytes, storage 200 gigabytes. This is fine. Okay, let's add this default server here. We have 10 of these default servers. Let's add additional workload here with this Add Workload button. The next one, we have virtual SQL servers. And as you can imagine, the SQL server has some additional requirements. So the SQL Server total count of VMs, we plan for a high available SQL Server implementation on the virtual layer. We have maybe 8 virtual CPUs for the SQL Server, maybe 10, maybe 12. You can configure this. The recommended vCPU to physical CPU relationship is 1 to 3. This is different to the default server. Memory 32 gigabytes, storage 1 terabyte. I will use these default values, but you can imagine you can here add your values. You can here add the values you expect for your implementation at your customer scenario. Let's add this workload here. Let's add another workload. Let's add the Exchange server. You know, we have still a recommendation for Exchange for physical installations, but we can run the Exchange virtual. We have a total count of VMs. We also want to have 2 of the VMs. We have virtual CPUs. Let's take 8 of them. We have a virtual to physical relationship in Exchange with 1 to 1. Memory, we have a recommendation for 128 gigabytes of memory. We can use this 128 gigabytes here, or we can decide for choosing less, and maybe we have 2 terabytes of storage. And then maybe we have some additional workload. So maybe we have some VDI VMs. So we have the VDI VMs, so traditionally client desktops with Azure Virtual Desktop. We have a great VDI implementation we can use. Let's check for VDI here. The recommendation in VDI, let's say we have 4 of these VDI VMs, vCPU 2, virtual to physical relationship 8, memory 2 gigabytes. Let's add these machines. You can see here we configure our expected workload. We can redefine this workload in a later time because we can see I'm logged in with a user account and this is required. So next step, the results. So the planning tool tries to find a solution based on my selections. So I had a preference regarding the vendor, regarding the CPU. I had the configuration regarding the workload. You can see here, I can edit both. I can edit the preference. I can edit the workload. And I see the result. The recommendation based on my values is to have 36 cores, 2 sockets with 18 cores in each socket, memory 384 gigabytes in each of the servers. Total number of servers is 2. I didn't check the checkbox that I want to prefer 2-node configurations, but here we can see this workload is suitable for a 2-node configuration. Then we have 31 terabyte of capacity drives, 4 times 8 terabyte SSD, and we have 3 terabyte cache drives. I didn't check the checkbox that I prefer full NVMe deployments. So I have an optimized configuration regarding the costs here. Let's have a look at the CPU and memory. When we highlight the CPU configuration, I will see here, actually 27 cores are in use. You remember, I had this virtual to physical relationship I configured. I had the number of virtual CPUs per VMs, and this is what was calculated. I have 6 cores for future growth. These are my 20% I configured. I have leftover 3 cores. So I have 3 cores when I consumed the capacity I planned for future growth. I have 3 more cores. So we could say we have 9 cores for future growth. And for sure, Microsoft will always configure an reserve for the hardware, for the host operating system, and so on. Here you can see this is total used future growth, leftover, high availability. This is what's not used by virtual machine workload on the physical hardware based on the planning. And then we can see we have the high availability. For sure, you have to plan for redundancy because if you equip both servers in this 2-node configuration with the maximum workload, then where are the resources for a failover? If one server fails, you need resources on the remaining servers to start the failed workload. This is the usual is the situation we have in a cluster. And this is the reason why in this configuration, both nodes have 36 cores, and I will not leave one node free for failover, but I will have in this 2-node configuration 50% resources for the failover situation. So 50% for the workload and the other 50% for failover scenarios. It's important to plan with this. I often see clusters in production that are over-provisioned, especially in these smaller configurations with only a few nodes. Let's have a look at the memory. The memory was planned with CSV and SBL. You can always get an information here, the in-memory cache and the SBL cache. We have for Hyper-V the 30 gigabytes, and we have for the workload 240 gigabytes. For the future growth, we have 48 gigabytes. We have 37 gigabytes left over. This is based on the module size. We can see in the configuration we have 24 times 16 gigabyte DIMMs. Usually the DIMM slots are fully equipped to have the maximum performance. Usually we have some capacity overhead because of the DIMM size and the module number. So here we have some left over here. And for high availability, we have 348 gigabytes. For sure, in a two-node cluster, the relationship between usable capacity and leftover for high availability is 50%. In a three-node cluster, we have 33%. So the efficiency can be increased with adding additional nodes. But I already mentioned in one of the previous modules, it's not the situation that you should build clusters with as many nodes as possible. The recommendation is to keep the clusters small, but to ensure that you have enough nodes for your workload and that you can optimize for your resiliency needs. If you need a two-way mirror, nested two-way mirror, three-way mirror, or double parity. Regarding the storage, you can see here we have used, based on our planning, 9 terabytes. Resiliency is 26 terabytes. Future growth is 7 terabytes. And we have a leftover for 4 terabytes. And we have a reserve of 15 terabytes. So if you wonder, we don't have this 50% cutoff here because in CPU and memory, we will consume the value that's planned for high availability here and also in the memory section if one node fails. The resiliency is also taken when all nodes are up and running because we cannot build the redundant blocks, the redundant extents for storage spaces direct. When a node fails, we already have to build the redundancy when the volumes are created and the data is written. So when we have a look at this resiliency, we will get information about the different resiliency types that are chosen. And here in this configuration, we have a nested resiliency because we have seen we have 2 nodes. This is the total quantity we have here. And when we take 2 nodes and we want to survive 2 simultaneous storage failures, and I selected this when I made the specifications for this configuration, I need a nested resiliency. This means a hard disk drive can fail in node 1 and a hard disk drive can fail in node 2. Or we don't have hard disk drives, we have only SSDs and NVMEs here. But we can also have an outage of one node and an additional disk failure in the remaining node. So the interesting thing is, what is this reserve here? Because you can see we have a reservation for our 20% growth we have planned. We have some left over. It's similar to the memory and the CPU based on the sizes of drives and so on. We have some leftover capacity, and we have always some leftover capacity because of some technical requirements or technical specifications. The reserve is a capacity that Microsoft recommends to keep free to allow a parallel local rebuild. I will explain this rebuild in the next planning tool we will have a look at. Important is to know that we don't have some hot spare drives here. So all the drives that are taken, 4 times 8 terabyte SSD in both servers, so 8 times 8 terabyte SSD overall, all these drives are taken to store data. but we keep some free space on each of the drives to ensure that if one drive fails, we can rebuild the data on this drive with the reserve capacity of each of the remaining drives. So it's a great idea to not have this not used hot spare drive in our pool till one disk fails, but to use all the drives and to provide some hot spare reserve capacity on each of the drives. In the last section, we can see IOPS sizing is coming soon. When we scroll back to the top of the page, we can see the sizer is actually in preview. So this is a very new tool. It's provided for Azure Stack HCI, and the information about CPU, memory, and storage is already known at Microsoft because this is part of the certification process for the hardware. This is part of the private cloud simulator. The performance values were not provided in the past. Now Microsoft is starting for the new systems to provide also the IOPS information in this sizing tools, and Microsoft gets the IOPS information from the OEMs. They test their servers on the standardized processes, and so we can use this here. The assumptions here are important. This tool finds solutions that potentially meet your requirements based on hardware data provided by the solution builders. Yes, the solution builders, the OEMs provide this data, but based on a standardized process. So I cannot manipulate anything here, but for sure I can configure a system that I will never sell. This doesn't make sense from the marketing perspective, but it would be possible to assign a system only for certification process here. Usually you can get all these systems in the market. Sometimes you have some very new technologies where maybe you have some delivery times till you can really order it. The sizer assumes you are running Azure Stack HCI. Could also be possible your storage space, you're running storage space is direct in Windows Server 2022. This sizer is focused on Azure Stack HCI, and networking is no factor in the sizer. So we don't have information about recommended port bandwidth and things like this. It's about CPU, memory, storage, and we will see IOPS values in the future. We see configuration. Here we can get this system with 2.5-inch disk drives and 3.5-inch disk drives. And for sure, I can jump to the catalog listing in the Azure Stack HCI catalog. Let's open this in a new tab. There we can see, this is the system in the catalog. I can see the optimized workloads. I can see the different configurations Primeline solution offers here. So NVMe SSD, SSD only, SSD hard disk, NVMe SSD, and so on. And I can jump to the solution builder side. This is the website of the solution builder of the OEM that provides this system in the market. So let's go back to the sizer and let's change some values. So I can close here or go to the previous side. Let's choose the close. Let's imagine I'm finished with this project. I will create a new project or I will reopen the planning 03. And here we can see I can change values. Maybe I have a future growth of 30%. Yes. And maybe I have a different workload. So here I can see I have this default server configuration and I have chosen to have 10 of them. Maybe we have 30 of this SQL server, of these default servers. And maybe we have also more VDI VMs. Maybe not 4, but maybe we have 8 of them. And maybe we don't have the traditional VDI, but we are using Azure Virtual Desktop. In Azure Virtual Desktop, we have technology. It's called Windows multi-session, Windows 11 and Windows 10 multi-session or multi-user. This multi-session or multi-user technology allows us to have several user sessions on a virtualized Windows client. And in this configuration, we need more virtual CPUs, and maybe in this, not maybe, in this virtual to physical ratio, we should choose a 1 because we are using this multiple sessions in the VM, and we have to ensure to have best performance in each of the sessions. And in this scenario, maybe we have 32 gigabytes of memory in each of these machines. So we have the VDI changed, maybe we have the exchange, and we want to increase the size here of the memory. You can imagine we can change these values if we get new information from our customer, updated information. Maybe we had the first check of the existing network and we update these values here. Now, when I go to next, the sizer again tries to find values. And now we can see, oh, I have a total quantity now of 4 servers. So actually, it's not possible in a 2-node configuration, or it's not recommended. You remember the choice in the first step. There I could have chosen the option, I want to try to have the 2-node configuration if it's possible. Here we can see each of the servers has larger CPUs. It has 22 cores. We have the 384 gigabytes memory in each of the servers. We have now 31 terabyte storage capacity in each of the servers. And now I can see the N+1 cutoff is not at 50%. We had this in the 2-node configuration, but now it's the capacity of one server, but we don't have this standby server or failover server, but the capacity has to be kept free across the servers to ensure if one of these 4 servers fail, that the 3 remaining servers can keep the workload. In a 4-node cluster, we could also say, okay, we want to survive 2 node failures, not only regarding the data redundancy. This is chosen where we set how many disk failures we survive. But we could have chosen the option to say we want to have a redundancy N+2. Then we would have the situation that in this configuration, we would get configuration with 5 nodes. Because Azure Stack HCI sizer would say, okay, the customer wants to have N+2 redundancy, N+2 cut over. In this situation, we need the capacity of 2 servers to be able to handle the failover. Again, not as dedicated failover servers, but we need this capacity free across the servers, kept free. Okay. We have the CPU cores, again, the information about used, future growth, leftover, high availability. Then we have the memory configuration. We see for the workloads, nearly 700 gigabytes, future growth, nearly 200 gigabytes, and the storage capacity. Here in this configuration, we can see we have the 3-way mirror. I've chosen optimized for performance. This is where we get full flash configurations regarding the drives, and we get the 3-way mirror, so 3 copies for each extent. And here we can see 14 terabytes capacity is used, 28 terabytes is for resiliency, because a slab, an extend that is written to server 1 gets a copy on server 2 and a copy on server 3, and a copy of the slab that's written to server 2 will get a copy on server 3 and server 4. So each of the servers will have original extents. Each of the server will hold copy 1 and copy 2 slabs. We have seen this in one of the previous modules where we have seen how storage spaces direct distributes the extents across the servers. Okay, let's plan for another solution. We have seen that Primeline solution also has the AMD-based systems. Let's make planning 04. Now we already know how it works. We can have the project nodes. We can select the preferred CPU. Let's select for AMD. We have the solution builder. It's the Primeline solutions. We have the advanced values, high availability. This is when I choose N+2, then I will be able, regarding the resources, regarding the capacity, to survive 2 node failures. Storage failures to tolerate. Recommendation is always to have 2. Storage type, I prefer an all-flash configuration, optimized for performance, future growth, and then I go to next. I want to add some workload. Let's again workload the general or the default server. We have this total count of VMs. Let's take 10 here, and let's add a workload based on the SQL configuration. Let's take some more SQL servers. We have in this configuration 4 SQL servers, and we have more memory in each SQL server. Let's add them here. And now the result will be a different system configuration, because now we will have the AMD-based configuration. Here again, cores, memory, storage, CPU, memory cutoff, storage usage. I think you have seen the Azure Stack HCI Sizer is a great tool to plan your Azure Stack HCI solution, to select for a solution, and to play a little bit around with the planned workload to see how to optimize the solution. If you want to focus on the planning of the disks, there's another calculating tool. It's not as powerful as the Azure Stack HCI Sizer, but it helps you to understand how the different disk drive types work together. The Storage Spaces Direct Calculator is not a recommended full planning tool. You can see here Storage Spaces Direct Calculator preview. This calculator is provided by Cosmos Darwin, who is a principal program manager at the Azure Stack HCI team of the Azure Group at Microsoft. You can reach this calculator via aka.ms/s2dcalc, and we also want to have a look at this calculator. The Azure Stack Sizer provided a full configuration, but it didn't give me the flexibility to say here, oh, let's have a look how the configuration is if I choose for 8 4-terabyte hard disks as a replacement for the 4 8-terabyte hard disks. And exactly this optimization or this configuration and choice can be done in the Storage Spaces Direct Calculator. Because in the Storage Spaces Direct Calculator, we can first say, okay, we plan for a 2-node solution. Maybe you have as a result in the Azure Stack HCI Sizer the result for a 2-node configuration. And you see here you have the 4 times 8 terabyte SSDs. And now you want to find out if the 4 times 8 terabyte SSDs is a perfect configuration for you, or if you want to plan with a different size. Yeah, let's see here. Okay, 4 times 8 terabyte. What happens if we have 8 times 4 terabytes? Let's have a look at this reserve capacity. When I choose for 8 times 4 terabyte, I have a reserve of 8 terabytes here. It results in 32 terabyte of physical capacity in each node. This is not the usable capacity. This is the physical capacity in each node. Let's go back to 4 times 8 terabytes. And you will see the result of physical capacity in each node is the same. But now we have 60 terabytes reserve. What does this mean? Let's take an easier disk configuration. Let's take 4 times 4 terabyte SSD. Here we can see we have a reserve of 8 terabytes. We have 12 terabytes usable capacity, and we have 12 terabytes for resiliency. These are these 12 terabytes here. Important, storage efficiency is 50%, but it doesn't calculate with the nested resiliency. I have a 2-node configuration here, and the storage spaces direct calculator we are using here only understands two-way mirror. So if you plan for nested two-way mirror, you have only 50% of this capacity. So this means 6 terabyte with nested two-way mirror. It's important in the 2-node configuration, 50% of this usable capacity. But this is not what we want to calculate here. We calculated our capacity in the Azure Stack HCI sizer, and now we want to optimize the amount of our disk drives, and we want to focus a little bit on the reserve. How does this reserve exactly work? We have seen I have chosen a configuration with 4 disk drives with 4 terabytes. It's our SSDs. I have 4 SSDs in each server with 4 terabyte capacity. This means I have 4 drives, and when I keep the reserve, each of these drives will be filled up with maximum 3 terabytes of data. So we will have 3 terabyte here, and we will have 1 terabyte here. This is free space. And this on the left-hand side is used capacity. This means if one of the drives fails, let's say this drive, then we had 3 terabytes of capacity on this drive. This was the capacity that was used. Now we can rebuild these 3 terabytes of capacity with 1 terabyte here, 1 terabyte here, and 1 terabyte here, because 3 times 1 terabyte are 3 terabyte, and with 3 terabyte I can rebuild the full amount of data, and we didn't have any data loss with this outage of the disk, because yes, the disk failed, but we have the extents distributed, full redundant across the servers, and so this information can be rebuilt. This is the great thing about the reserve capacity. And as you can imagine, the recommendation is to keep the capacity of 1 disk drive in the server for reserve, distributed across all the drives in the servers, to ensure that you can survive a disk failure. This is always the situation if you configure the resiliency correctly. And you can also rebuild a drive after disk failure without replacing this drive. For sure, you will replace the failed drive. But if a drive fails in the middle of the night, maybe you will get a replacement drive at the next business day, and you replace the drive to the business hours. But your workload has still to run, and you want to access your data. This is provided by the resiliency. But with this Local rebuild based on the reserve capacity, you have the advantage that after the rebuild finished, you have your full redundancy back. And so you can imagine if you choose for smaller drives, then the capacity needed to survive the single disk failure is smaller. Let's take 2 terabyte drives in this scenario with a count of 8 of them. Then you will see we only have 4 terabytes of reserve capacity, because now on these 2 terabyte drives, we have less capacity on each drive, because if one drive fails, we only have to rebuild that used capacity on this drive now on the 7 remaining drives, and not in the 4 remaining drives we had previously. So this scenario was easy to understand, the capacity calculator. What the message is, if you plan for a configuration like this, for example here 2 4 terabyte drives for NVMEs, let's take 8 terabyte drive NVMEs, and let's take, for example, 8 16 terabyte drives, SSD or hard disk, then we will see we have 32 gigabytes of reserve. Maybe it's a better choice to say let's have 16 drive with 8 gigabytes here, because we have less reserve. Now we only have 16 gigabytes. It cannot display it in the calculator here, but this gray reserve is now 16 gigabytes. It's the capacity of one drive in each server, and we have planned with 2 nodes. So our efficiency is much better than before. The capacity is the same. It's 128 terabyte in each node. You can check this when I go to 816. The rebuild time is less because we had less data on one of these drives. For sure, you have to find a suitable relationship between number of drives and capacity. It will be possible to have the 16 8 terabyte drives instead of the 8 16 terabyte drives. But maybe it will be difficult to have the 32 4 terabyte drives, because maybe your server does not have 32 slots, and the recommendation is to have maximum 28 drives in each server. This is a recommendation, but the number of slots is typically limited, and so you will have to play around with these values here. What I want to tell you, please ensure that you don't focus too much on these ultra large drives. Always check if there's a suitable configuration, maybe with a moderate drive size, where you can optimize the reserve capacity and where you can optimize the rebuild times. We will see the reserve capacity again in a later module when we use Windows Admin Center to configure storage spaces direct in Azure Stack HCI and to manage storage spaces direct in Azure Stack HCI. Let's focus on another important point here in the configuration. Let's go back to a basic configuration. Let's have 2 800 gigabyte NVMEs and 4 4 terabyte hard disk drives. Here I can see I have 16 terabytes of physical capacity per node, 4 times 4 terabyte here, and I have 1.6 gigabytes of cache per node. It's an important requirement to understand that Microsoft says in hybrid configuration, your cache drive capacity has to be minimum 10% of the capacity. This is exactly what I've configured here. 1.6 terabyte is 10% of 16 terabyte. So I have the 10% of the physical capacity here for the cache drives. It's okay to have more. It's okay to say we have 1.2 terabyte, This is a better cache to capacity relationship. What's not okay, to have less than the 10%. Here we can see we only have 5% cache from the capacity. This is absolutely not recommended, and that's not supported, because if the cache is too small, we have issues with the drive endurance, because we have, regarding the capacity, more load on the drives, and we have limited performance here. So minimum 10%. I would recommend to have 10% plus. So in this configuration, I would use, for example, 20% cache drive relationship. It's perfect for this hybrid deployments, because as we have learned in one of the previous modules, the cache optimizes how the data is written and read from the hard disk drives, because we have learned that the hard disk drive is optimized for sequential workload. It's not perfect for random I/O. Another point that is important is here to know that we can deal with the nodes. I started with a 2-node configuration, and I mentioned that you should keep in mind that this 50% storage efficiency, so this 12 terabytes here, are based on the two-way mirror in the 2-node configuration. Here we have 50% of the capacity if we use a nested resiliency, what I recommend to you to do. In a 3-node configuration, we always have the 3-way mirror. So the usable capacity doesn't change, but we have an additional node, so additional cores, additional memory capacity. We have 33% efficiency regarding the storage, but also regarding the CPU and the memory, because as we have seen in the Azure Stack HCI size, we have to keep reserve capacity for exactly the failover situation. Starting with 4 nodes, we get an additional slider here where we can decide for 100% mirror. Also in the 4, in the 5, in the 6-node cluster, we have a 3-way mirror here in this as a redundancy option. What's new, starting with the 4 nodes, is to have an dual parity. Dual parity is not RAID 6, but for easier understanding, it can be compared with RAID 6. So we have our original data blocks, our original data extents, and we have 2 redundancy information for each of them. So we can survive again 2 simultaneous independent storage failures. When I move the slider to 100% mirror in my configuration, 800 gigabyte NVMEs, 4 times 4 terabyte hard disks, so very small drives, I can see I can start with 16 terabyte usable capacity with a 100% mirror. I can get up to 24 terabytes usable in a dual parity. But important, the dual parity has to be calculated, and the calculation is done by the CPU, and Azure Stack HCI is paid based on the CPU cores. So my recommendation would be to focus on mirror. It's faster and it's cost efficient regarding the cores. What you saved at the cores, you can invest in additional capacity. From the technical perspective, a great option is to have a mix of it, and this is possible. Storage Spaces Direct in Azure Stack HCI is capable of building multi-resilient volumes. So you could build a volume that, for example, has 50% mirror and 50% dual parity. Or we could say, okay, let's take only 30% mirror for acceleration And let's take 70% dual parity for capacity optimization. This is possible. When you combine these two great tools, the Azure Stack HCI Sizer, and then for fine-tuning the disk drive selection with the storage spaces direct calculator, the capacity calculator, you will get a perfectly designed Azure Stack HCI solution.